Hello. Okay. I think we can start our class today. Okay. Okay. In previous week, I already introduced to you about the arrows, delays, opening, closing, and a combination of them example using the few hole algorithm, right? Few hole methodology. And today we will go to another morphological image processing we call hit and miss. Hit and miss. And okay, so what is it? What is it? So hit and miss is some kind of like the object recognitions, right? Simple object recognitions. And it just work on the binary image. Okay, so uh, pay attention here, right? The remark here just work in the binary image. Okay, so how can hit and miss algorithm can do the simple object recognition or some kind of like looking for a particular pattern. Okay, uh, it will follows by this equation. This equation. From this equation.
Hello there.
Okay, sorry, the internet, they have problem, similar problem with similar in the morning. Wow. Okay, sorry. Okay, let me explain again. Okay. Hello, hello, các bạn có nghe mình nói không? Hello.
Có thôi.
Dạ có.
Cái internet vấn đề rồi. Hồi nãy mình đã nói xong cái slide này chưa? Các bạn đã nghe hết slide này chưa?
Dạ tụi em mới thấy cái chữ hit and miss luôn đó thầy.
Nữa đang nói slide trước đó thầy.
Slide này hả?
Đúng rồi thầy chưa nói được gì slide này hết.
Chưa nói hết luôn hả? Trời ơi, chết. Ok, để mình nói lại. Okay, I explain again. Okay, wow. Okay, hit and miss transform. Okay, so what is it? Hit and miss transform, they will follow by this equation. Okay, if you cannot hear my voice, so you just how to say, inform me by the cell phone, right? Just call me. Okay, so the hit and miss transform, they will follow by this equation. Okay, so in this equation you can see that you have two kernel, B1 and B2. So the hit and miss transform is the algorithm to find the shape match B1, but not match B2. Wow, match B1 but not match B2. Okay, not B1 but not B2. Okay, so how can it perform it? How can they perform it? So this one you can see that this is the symbol of the hit and miss transform. Okay, and this is what is the symbol of it? What is it? What is the symbol of it? This is the symbol of the arrows, right? Arrows, right? And this is the symbol AC. What is it? AC. See, this is the complement, right? The complement. What is the complement? The complement is 0 become 1, right? And 1 become 0. That's the complement, right? This is the complement. Okay, so the equation is that first you arrows with the kernel B1, right? And then you complement the image and then arrow with B2 and then and the result and the result. Okay, so let's go more detail. Okay, and this is example in the kernel here. You can input 1, 0, right? And beside it, you can input the -1. Okay, so here, example here. This is the B1. And this one is B2. And this one is B. Right? B1 and B2, I already explained to you, right? But what is B? What is the kernel B here? The kernel B here is the combination of B1 and B2. The combination. So what does it mean? So let's have a look at B1. So in the B1, right? In B1, they have the number 1 is the 255, right? So 1 will equal to 255. Okay, 255. So this one is B1, and we want to find in the image. Where is B1 in the image, right? Where is the B1 in the image? But different with B2, right? So we perform the algorithm, right? A arrows B1, right? A arrows B1, right? So they will find the where is the B1 inside, right? Where is the B1 inside? And then they will find AC. This is B2, right? So how can we have B2? As I said before, they will provide you normally they will often provide you B1 and B2 like this one, but normally they just provide you B1, and then you have to find B2 by yourself. Normally B2 is B1 complement. So that means this is B2. This is B2. Okay. And the B is the combination with B1 and B2. So here you can see. Here you can see. 1 become 0. 1 become 0. 1 become 0. 1 become 0. Right? And 0 become 1. 0 become 1. So the element that complement is the element we care. The element, the remaining element here you can see 0 but still 0, 0 but still 0, 0, 0, and 0. So the 4 0 at the corner here is the element we don't care. We don't care. Okay, don't care. So you can perform the algorithm by using this one. And you have another kernel to define here. Is that one is similar 255. Minus 1 here, be careful, minus 1 here is 0. So here you have to find exactly where is 0 inside. Where is 0 inside? So the template is that 1, 1, 1, 1, and 0 inside. Okay, 0 inside. The 0 remaining is don't care. Okay, so let's go to the example for clearer. Okay, yeah, this is the example. I give you B1 here. B1 here, right? B1 here. Okay. How to find B2? How to find B2? So, example, I want to find exactly this position. 1, 1, 1, 1, and then 0 inside. Yeah. And for remaining position is don't care, and don't care. So I will do the complement of B1. Right? So what 1 here becomes 0, 1 becomes 0, 1 becomes 0, and 1 becomes 0. Okay, and 0 here become 1. And the remaining still the same. So because I don't care about this. Okay. So the first is the algorithm is that we will do the A, right? Arrows B1, right? Arrows B1, right? When we arrows with B1, so which position E1? Is it this one? And is it this one? Yeah, right? Is it? No. Just this one, right? Just this one. right? Just this one. Because here 1 1 1 1 and 0 here, right? 1 1 1 0 here. Oh, sorry, we errored with B1, right? Errored with B1, so we just sorry. When we errored with B1, we just care about one, right? Errorism, right? So this one is one position here, right? Because 1 1 1 1 here, right? And another is 1 1 1 and 1 here, right? So after the first algorithm is a error B1, we have two position, right? We have two position, okay, two position, right? And then we do perform and, right? And with AC, right? Errors. This one, right? B2, right? B2, okay? AC error B2. So after this one, right? And then we end, So this one will be delete. This one will be delete. Okay. So that's we apply the algorithm. But in the OpenCV, they will provide you a function. But in the function, they do not use B1 and B2. They do not use. They use the kernel, like the combination kernel. So we have to define the combination kernel for the programming OpenCV. Programming. So how can we define it? As I said before, right? One here is 1 is 255, and minus 1 is 0. Okay, minus 1 is 0, and here they don't care. And then we can use this kernel for programming. And you can use this kernel for directly look at this one, right? Look at this one. Example, if you use this kernel, to look at in the image, right? So where is it? Is it this position? Yeah, just this position. Certify the kernel B. Okay, certify it. Okay, so okay, let's have an exercise. Okay, B1 and B2. Okay, let's have an exercise. Okay, so now example, I will define a kernel. Let me what's the word table? Is it better? Okay. Example, I define the position like this. Okay. This is B1, right? This is B1. Okay, let me say. Okay, example, I want to find the position like this. 0 1 1 0 0 0 1. Okay, so I want to find exactly 6 position. Okay, so can anyone tell me the B2? Can anyone tell me B2? If I define B1, right? And I want to find exactly the position of this one inside the image, right? So can anyone define the B2 for me? This is the B1, right? B1, okay. B1, okay. So can anyone find the B2 for me? Okay, let's please. Okay, see. Let me see. Insert the, okay, this is B2. Okay, let's define B2. Let me define B2. Okay, so what is number here? Can anyone tell me? Because I just want to find exactly position here, right? So I just complement this one, right? So this one will become 0, 0, 0, 0, right? And then this is 1, 1, right? And this one, don't care,
0,
right?
0, 0.
Is it? Yeah. Okay. So that's how to define kernel B2. Okay. Or the hitmiss transform or algorithm. Okay. So from here, I want to define directly kernel B. So what is it? Exactly kernel B. Exactly kernel B. Exactly kernel B. So can anyone tell me exactly kernel B? What is it? What is number here? 1, 1, 1, 1, and this one? Minus 1, right? Minus 1, right? And this one? Don't
0,
care,
0.
don't care, don't care, right? Okay? Yeah. Okay. So do you have any question? Very important. Yeah, it's very important. Yeah.
So the magic in B, yeah, E minus 1 when we coding is E 0.
Yeah, correct. Yeah, correct. This one is for programming using function, OpenCV function. You have to define the kernel like this. You have to define the kernel like this, right? And this one is also directly, right? Look into the image, right? Look into the image. Okay, let's go back to the slide. Okay. Okay, this is the OpenCV function here. And the OpenCV function, they call this morphology AX. Okay, so you have to provide the source destination and the option here. The option here is you can choose, and this is you can have to choose the like the hit and miss, right? Just CV dot 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 dot, and then you have the list here, and then you choose the hit and miss here. Okay, and then this is the kernel, right? You have to define the kernel, and this is the entry point, and we make the default entry point at the center. Okay, and this is the iteration, right? Iteration. You just let this default one. We just want to do one iteration. Okay, and the border types, you have to look at the header, right? And then this one is default. Okay, this one is default. Okay, let's have a look at the code. This one. This code is the for previous image. This one is to define the image. Okay, to define the image. And then you define the kernel. Here you can see that they have to define the kernel, the combination kernel B. Okay, and then just put it in the kernel here, right? And then here you choose the hit and miss, right? Just input image and output image. Okay, the remaining is just for showing, just for showing. If you don't get familiar with the remaining code, just output the image for me. Just output the result of the output image. Okay. So after you perform this code, you will have the result like this. You will have this one. Okay. And another some example, some more example here. Example, they want to find where is this position in the image. So again, right? 1, 1, 1, and this is 0, 0, and 0, right? So let's find it. Is it this one? 0, 0, and 0, right? Is it? You see, don't care, right? Don't care, right? Don't care, right? So is it this one? Yeah, this one here. Okay. Is there another? This one, right? 1, 1, 1, right? And the remaining 0, 0, and 0, right? And this don't care, right? So this one, right? Can you find another? Oh, the internet have problem. Okay, so this is another example, right? Another example. So this one, right? We have to find the position of 255 here, right? And this is the 0, 0, and 0 here, right? And then when you look directly on this image, right? Where is it? Where is it? Where is it? So this one, is it 1, 1, 1, right? And this one is 0, right? 0, 0, 0, and the remaining we don't care, right? The remaining we don't care. So this one is this position, right? And where is it? Is it 2, 2, right? And then 1, 1, 1 here, right? And this is 0, 0, 0, right? And this is don't care, don't care. Okay, so from this example, hello, can you hear me? Okay.
Yes.
Okay. So from this example, if I give you the exercise, so your task is to define the kernel, to define this kernel. So this kernel is look like you find the corner point. This is the corner, right? This is the corner, right? This is the corner point. This is the upper right corner. Example, I ask you to find the upper left corner. So you have to define by yourself B1 and B2, or you have to define the combinational kernel B. Okay, so this is your task if you have the exercise. Okay, so and another kernel is here is the like define the endpoint kernel. Endpoint example, you have the line like this, so this one is the endpoint, so this one you have to define this. And please be careful that the kernel is not just 3 by 3. It can be 5 by 5 or any 7 by 7. Yeah, right. So be careful about this. Okay. So this is the basic hit and miss. Okay, basic hit and miss. So do you have any questions on this one? Because this one is very, very important. Okay. Okay, so let's go to the next algorithm. So now we go to the more complicated one, thinning. So what is the thinning? Example, you have the line, right? And this is the Y of this is 7 pixel, right? 7 pixel. So you can apply this algorithm to reduce the Y of this. To example 5, 4, yeah, any right, any Y here example to 1, of course cannot 0. Okay, right, to 1. So how can it do it? So this one is they will apply this algorithm. Wow. So here you can see that they will use the hit and miss transform, hit and miss algorithm. Okay, so what is it? What does it do? They will hit miss with kernel B, right? And then they use original image minus with the kernel with the result. And by doing it many iterations, by using the A kernel, and here equal to from 1 to A. Okay, from 1 to A kernel. Doing the thinning. So that means this one. Wow, that means this one. Okay, let's go to the more detail. So as I said before, this is A kernel. They already define for you. So you just apply it. And here you can define the kernel. What is it? This is 1, and 1, right? X here is don't care. And the remaining is 0. Okay. So the first is what is it? We have the original image, right? And the first is we use this original image to thinning with B1. So what is it? What did we do? A minus, right? A hit miss B1, right? And this one give the result A1 here. Okay, and here is the result. Okay, this is the result. And then we obtain A2. So what is it? So we apply again apply again the thinning algorithm with kernel B2. So A1, right? A1 minus A1 hitmiss B, right? B2, right? B2. And after this step, we have A2, right? A2. And then continue. You have A2, A3, A4, A5, A6, right? And then AA, right? Here this is just AA, right? Just do 2 times with B7 and BA, right? B7 and BA. And then again, right? Because you already use the BA, right? BA here. And then you again another iteration with from B1 to B4, and you have this one, and then you have B5 with B5, and then you have B6, right? B6. And then when you apply with B7, they do not change anymore. So this is the result. You can see thinning, right? Thinning, this one. Thinning. Okay. So let's go to the example of your exercise. Okay. Let me see. Where is it? Okay, here. Okay, here. Let me see. Where is it? Let me see. This one is it? Yeah. Okay, here. Thinning. Example, I give you this image. Wow, where? Okay. Example, I give you this image. Okay. And then apply the thinning algorithm on this image. Okay. So this is the A kernel, right? This is the A kernel. Similar to the slide, okay? And then you perform the thinning by hand, okay? First you perform with kernel B1. So I hit with B1, right? Hit with B1. So where is it? Hit with B1, right? So this is the combinational kernel, right? So it's very easy for you to watch here. So just look at 1, right? 1, 1, 1, and minus 1 is 0, right? Minus 1 is 0, right? Minus 1 is 0. So if we betting here, right? If we betting here, and then apply this one in, and you have this one, right? You have this one. Okay, and this one also. Okay, this one also. Okay, and then you use the original image, right? Minus this, you have A1. When you have this one is the A1 here. And then you use the A1 image here, hitmiss with B2 again. And then you have this one. And then you let the A1 minus this one. Right? A1 minus this one. And then you have this one. And then just continue. And then you have the result is this one. Okay. Yeah. This one. And then this is the code for you. And this is the code for you. Where is it? Oh, wait. And this is the code for you here. Where is it? Okay, this is the code, and let's have a look at the code. Okay, so define the image, right? And then define a kernel, 7 kernel or a kernel. Okay, and then apply, right? Morphology, right? Hitmiss, right? And then just minus, and then use the sort again, right? The result, right? Result here. Hitmiss again, right? With B2, right? And then minus again, right? And then minus and minus again, and then you have this one. Okay, you have this one. So this is the result. Okay, this is the result. Okay. So do you have any questions on this one? Do you have any questions? Okay, after you have the exercise, you will have the question, right? Okay. Okay. Go to another example here, right? If you have the image, right, and then you can apply the thinning algorithm, right? Here I just apply one iteration, and then you can see the result, right? It's thinning, right? It's thinning, right? And then if you apply more and more iteration, then you will have this result. You will have this result. Okay. You will have this result. Okay. So let's go. Okay. And previous one is thinning, and now this is thicken, right? You have thinning, and then you must have thicken, right? So what is it? Okay. This will be performed by this equation. Wow. This equation. So the previous thinning is A minus A hitmiss B, right? Here, what is it? A, right? Not intersect, right? Union, right? A union with A hitmiss B. Okay. Right. And the kernel B is similar. You have to define 7 kernel, right? 7 kernel, and then you just hitmiss one by one, and then union it. Okay. But in practice, there is 2 methods for thickening, right? The first is you apply the algorithm like this, and the second is you do thinning first, and then you do complement, and then you have the result. Let's have a look at the second method. Example, you have to thickening this one. So what did they do? They complement, right? Is 0 to 1, right? 0 become 1, right? They complement, right? And then they thinning this one, right? Thinning this one, right? Here, thinning this one, right? And then complement again, and then delete this one, and then you have the result here. Okay, you have the result here. Another method is you will have the original image here, and then you apply the thickening algorithm, and then you have this one. Okay, let's have a look at the example. I give you this image, and then you have to perform the thickening algorithm. Okay, so what did we do? First, this is the original image, right? And then we hitmiss with kernel B1. And then hitmiss, and then we have this one. Is it? Is it? Yeah. And then you union, right? The original image and the output hitmiss, and you union, right? So that means you have this one, right? You have this one. And then let this one become the new image here, right? And then here you hitmiss with B2. B2. And then you don't have any result, right? So here, right? And then just step by step, 1, 2, 3, 4, 5, 6, right? A step, a kernel, and you have this one. You have the result, and this is the result of one iteration, thickening, right? So, and this is the code here. So this is the code here. So just do the hitmiss of the kernel, and then this with R, and then do another iteration. And then you will have the result similar with you do it by hand. Okay. And another okay, today you study many algorithms. Okay, and the next one, this is thinning, and the next one is skeleton. Wow, skeleton. Tìm xương ha, skeleton. So the skeleton is followed by these equations. So and you have to consider the SKA here. So SKA divided by this equation. Okay. So what did we do? What did they do? Okay, what did they do? So let's see. Okay, the skeleton is the step here. First, you arrows the soak with the kernel, and this is the kernel, right? And then you have the result of step 1, and then you dilate with the kernel again, and then you use the original minus with this one, and you have the new image. And then you union the new image here, and see. That I perform step by step for you. Okay. Okay, here is it better. Okay, let me see. Okay, example, find the image, the skeleton image of this one. Okay, so how can we do? Okay, first this is the soak, right? The soak, and then we do the arrows. Okay, let me pass to the pad, right, for easier. Okay, here, right? Okay, and where is the kernel? The kernel is the cross one, right? The kernel is the cross one. Okay, let me see. Okay, let me see. Okay, first what is it we do? What did we do? Here. Okay, we arrows, right? Arrows with this one, and after you arrows, you just have to position, right? Is it this one and this one? Right? Arrows, right? And then you have this one, right? And then you have this one. And then what did you do? You dilate this one. Dilate with the arrows with the skeleton here, with the kernel here, sorry, with the kernel here, and then you have this one. You have this one, right? And then what did you do? What did you do? What did you do? Minus, right? Minus, right? Minus. And then here you minus the soak, right? You minus with this one, right? This one minus this daylight, right? And then you have this one. And then the temp here, the temp here, right? The temp here, okay? And then the second iteration, you do this one, and then you arrows again with this one, and then when you arrow with this one, of course you have nothing, right? Have nothing, and daylight you will have nothing, right? And then you use this one minus with this one, right? Again, right? And then you have this one, right? Right. And then here you can see that if you perform the algorithm more, it does not change anything. Just have this one. Just have this one, right? So the result is, what is it? Union this one and this one. So this one is the result. This one is the result. Okay. Only the result. So I perform on this one for you. I explain more detail for you. Okay. So here you can see SKA here is, what is it? Errors B, right? Minus here, right? Errors B. Okay. So let's see. If K becomes 0, so what is it? A 0, right? K multiply B 0, right? And this one is 0 also, right? So this one is original image, right? Original image, right? Original image. And then what is it? This one is still original, right? And then original image daylight with, sorry, arrows and daylight, right? So you have this one. A minus, and then you use this one and this one minus, and then you have the SKA here. SKA here. Okay. So the result of K equal to 0 is this one. Is this one. Okay. And then K equal to 1. So A minus B, right? A is minus B. And then minus, oh, sorry. A arrows B, right? K equal to 1, right? K equal to 1, right? Minus A arrows B, and then daylight B. Okay. Okay. So A arrows B, right? This one is K equal 1. A arrows with B. B is the root kernel, right? And then this one is this one. Okay, A arrows B. Okay. And then use this one, right? A arrows B and A arrows B is similar, right? Daylight with B. And then you have this one. And this one. And then this one minus this one, and you have this one. And here you can see you union this one and this one. You have this one. And K equal to number 2. What is it? A errors to be 2 times, right? 2 times. So that means we use this one. Errors again, we have this one. Errors again have this one. Right. And then of course errors again here, and then delay would be errors would be you don't have anything here, right? And then here, and then after the result here you have this one. You have this one. Okay. So this is the function of skeleton. Okay. This I know that it's a little complicated. So I think that after the class, yeah, you can watch the movie again, right, and perform it by yourself first. Okay, so do you have any questions on this one? This is the procedure of the skeleton. Okay. Okay. I think that today I already give you many algorithms. So I just afraid you cannot catch up with the algorithm. So I just explain to you 3 algorithms today. In the next class, I will explain to you more another remaining algorithm. Okay. So do you have any question on this one? Okay. Let's see. Okay, threshold bigger than 0.98. So you just choose the result that's bigger than 0.98. Yeah. Okay, so if you don't have any questions, we can dismiss the class now. And I think that you should watch the movie again for more understanding. Okay. Okay. Thank you for your attendance today.